Hello children, for class 8 and 9, yesterday I discussed in my video the introduction of indices and exponentials and the laws of indices. Today I'll do some problems and a variety of sums where it will clear some of your doubts in indices, right? So before I start with my problems on indices and the various types, just remember this, some doubts to be clarified. And that is, suppose you have x by y to the power of minus m by n, where x, y, m, n are numbers, right? It's just a general way of giving. That is same as y by x to the power of m by n. This is the right one. It is not equal to sorry, y by x to the power of n by m. Don't make both reciprocal. Only the base becomes reciprocal and sign of the index changes. If the power has a fraction, only its sign will change when you make reciprocal of the base. Okay? That is wrong. So this is wrong. So I will not have it. Then your minus 1 by x to the power of minus m by n. And in the previous videos of mine, I told you minus x by y is same as x by minus y is same as minus of the fraction x by y. Okay? So we generally don't keep the minus with the denominator. So here also minus 1 by x minus m by n, the sign of the base does not change. It will just become reciprocal of this is minus x. Let the minus remain where it is. And reciprocal of this and just change the sign of the index. Don't make it reciprocal. So generally what children do, this is wrong. You have made reciprocal and change the sign of both, which is wrong children, and most of the children do this carelessly. So this is wrong. I will rub out the wrong. And some children do 1 by x and m by n. Yes, they keep this same, change the sign of this and change the sign of this. So this is also wrong. So what is correct? Only make it reciprocal, let the sign of the base remain where it is, and then only change the sign of the power. Okay? For example, when you have minus 27 by 8 to the power of 2/3, just changing the form before we solve the sum. So here it is minus. So minus 27 by to the power of minus 2/3. Reciprocal, sign of the base does not change. It remains as minus. Keep the minus where it is. Minus 8 by 27. You have a tendency to make it 8 by minus 27. Okay, but that is same as minus of 8 by 27 to the power of 2/3. Positive 2/3, not 3 by 2. Here also. Minus 1 by 243, yes, to the power of minus 5 is equal to minus 243. Reciprocal of this, sign of base remains negative as it is and sign of this changes. It will not become reciprocal. It will not become 1 by 5. So one I gave whole number negative, negative integer, and one I gave negative fraction. Okay, so I'll just show you the working of this. If you want to know the working of this, okay, so that is this one. You change it to this, right? And that is because it is minus, you have to write minus 2 by 3 to the power of 3. Minus 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 3 times is minus. Minus raised to odd power will be negative. Minus raised to even power will be positive. And that to the power of 2 by 3. So this gets cut. Power raised to power multiply. So answer is minus 2 by 3 square minus again even power. So answer will be plus 4 by 9. Similarly here minus 243. You will not write minus of. Okay, here you cannot write this minus inside by outside the power. That will be wrong. For example, the second sum you have. Okay, the second sum minus 243. After you simplified this, 5. You cannot write minus 3 to the power of 5 raised to the power of 5. Okay, this is incorrect. Though you will get coincidentally the right answer because an odd power. I told you minus 3 to the power of n is not same as minus any number to the power of n is not same as minus a to the power of n. This happens to be, same only when n is odd, right? Otherwise, actually it is wrong. Even you'll get wrong. So this is not the way to write. You have to write minus 3 by 5 to the, minus 3 by 5 to the power of 5. That is minus 3 by 5. So here, suppose I make it, let it be 1/5. So the fraction is 1/5. So it becomes positive 1 by 5. So positive 1 by 5. Okay. So now power raised to power multiply. Answer is minus 3. So minus 1 by 243 to the power of minus 1 by 5 is minus 240. This is 1 by 240. They will become minus 240. Sign remains the same. And sign of this changes. This won't become reciprocal. Right? The base becomes reciprocal when sign of index you change it positive to negative or negative to positive. Now let us go back to problems in indices. I will go from easy to hard, simple to complex. Let us first do the first example. 3a by b to the power minus 1 plus 2b to the power of a minus 1. Simple ones. So we do not touch the positive index, only the negative index. So we make it positive by making reciprocal. So what is reciprocal of 1 by b minus 1? b. 3a b to the power of 1. And what is this? 1 by a to the power minus 1 is a to the power of 1. And therefore, and the b here. The b here, and therefore 2ab and 2ba is same. So answer is 5ab. Is it clear? So let us take another example. Suppose you have minus. So I am keeping this minus 1 by 7 to the power of 3, 1 by 7 square and minus 1 by 7 to the power of 4. Okay. So here you have, now see this. Now you cannot write answer 1 by 7 to the power of 9 or minus 1 by 7 to the power of 9. Base is not same. Okay. A and minus a is not the same base. Therefore, first we evaluate this and make it all 1 by 7 or make it all minus 1 by 7. There is no minus 1 by 7 here, which we can write minus 1 by 7 square. This you can write as minus 1 by 7 square. It will all be 1 by 7 square. So the answer can be, so two ways I will show you. I can write this as minus 1 by 7 square also gives me plus 1 by 7 square. And this let it be as it is. Now because the base is same, minus 1 by 7 to the power of 9. And minus raised to the power of odd number is minus. So answer is minus 1 by 7 to the power of 9. 1 to the power of 9 is 1. Or the other way of doing this sum, yes, the other way of doing this sum is take minus 1 by 7 to the power of 3 minus raised to the power of 3 odd number minus 1 by 7 to the power of 3. This is already positive. And minus raised to the power of 4. So first I am raising the negative to the power and then the base. So minus raised to the power of 4 is plus and 1 by 7. Now the base is 1 by 7. Previously what I did, base was minus 1 by 7. So 1 by 7 to the power of 9, same answer you got. That is minus 1 by 7 to the power of 9. Is it clear? The next one. So you just read the sum. And then you have 27, next sum. So, is it clear? Now, let us go to the third sum. So, third sum is suppose 27 to the power of minus 2/3. Okay. And then we have plus 0.01 to the power of minus 0.5 into 0.125. Okay, into 0.125 to the power of 1/3. Right? So, seeing this and let this be minus. Right? If it's 27, you write as 3 cube. If it's minus 27, minus 3 bracket cube and the minus should be with the 3 in brackets. Right? So, here I will write minus 3 cube is minus 27. The whole thing, because minus is also raised to the power of minus 2/3. It's minus 1 into raised to the power of minus 2/3 and 27 to the power of minus 2/3. Okay. So here, so that is why minus is with the 2/3 and the minus 2/3 here. And 0.01 is nothing but 0.1 square. So here the index is a decimal which you can change it to fractions. 0.5 is half, right? 0.25 is 1/4, 0.75 is 3/4, 0.1 is 1 by 10. So the base you can keep it as 0.1. Okay, so you can write it as 0.1 square, 0.1 square raised to the power of minus half. 0.5 is minus half. Or you can write 1 by 100. You can write 1 by 100 raised to the power of minus half. And 1 by 100 is square of 1 by 10, which is 0.1. Okay? And 0.25, 125. If you do not know, it's 0.5 cube or 125 by 1000. And I taught you in my short multiplication that 125 goes in 1000 8 times. 125 into 8 is 1000. So therefore 0.125 when you reduce it to fractions is 1 by 8. So therefore which will be 1/2 cube. 1 by 8 is half cube. Or you can write 0.5 cube to the power of 1/3. Power raised to a power multiply. So multiplication, 3 into 2/3 is minus 2/3 is minus 2. 2 into minus half is minus half. And 3 into 1/3 is not 3 1/3. 3 into 1/3 1. So you got minus 3 to the power of minus 2 plus 0.1 to the power of minus 1 and 0.5 to the power of 1. 0.5 to the power of 1 is 1. Now 1 by 10, this is 1 reciprocal. Sign remains negative. I just now explained in the beginning of the class. Don't change this sign. Don't make it minus minus plus. Don't make this plus. The sign of the base does not change. Only it becomes reciprocal if you change the sign of the power. Okay. So therefore now 1 by 10. This is 1 by 10 to the power of minus 1 into, you can leave it as 0.5. Right? Now 0.5. Now here you can see that again reciprocal, and then we have to follow minus 1/3 square is 1 by 9, and this is reciprocal, so 10 by 1 is 10 to the power of 1, and this into 0.5. Now you have to do BODMAS, not add these two and then multiply. Multiplication first, then addition. So this is 10 into 5 and then 1 by 9. Yes, so you can see that 10 into 0.5 is 5. 5 plus 1 by, I've done a video on fractions, not 46 by 9 and change it to mixed fraction. 5 plus 1/9 is 5/19, and that is the answer. So this was minus 3 to the power of 2 minus 2/3. Let's check it. So minus 3 cube minus 3 square is minus 1 by 3 square, which becomes positive 9. Because if it becomes reciprocal, the sign will change. 0.1 to the power of minus 1 is 1 by 0.1 or 1 by 10. Reciprocal of that is 10 by 1. Sign changes. And here 0.5 cube is 0.125 or 0.125 is 125 by 1000, which is 1 by 8. And you can also write half cube here. Okay, and half cube raised to the power 1/3 half. Half is 0.5. So this is the answer of this sum. Now the next one which I am giving, there is a trick. Here there is a little bit of BODMAS. What are my intentions here? Of course, BODMAS application. Then how if the base is decimals and also index is decimals not given in fractions. So this is a new type. And then you have the fourth sum. Fourth sum has one intention of giving that sum, because whatever you make mistakes, I make sums accordingly. So for example, you have 216 to the power of 1/3 and you have a minus 625 to the power of 0.25, and then you have again a plus of 1 by 64 by 27 to the power of minus 1/3, and the whole thing raised to the power of 0. So sometimes, children, you have to use your, sometimes you have to use your, intelligence just to do the sum. Now there's a motive of giving this sum, right? I'll tell you that. So first thing is, I do not have to waste my time in doing this as 4 cube and 3 cube and cancelling the 3 and then making reciprocal to make it positive, and 1 divided by any number is reciprocal of the number. So 1 by x by y is y by x. All that, then you're doing 0. It's already raised to the power of 0. So do not waste time in simplifying this. Just write 1. Whatever answer you get, it is raised to the power of 0. And anything to the power of 0 is 1. You can write at the side, if teacher says how you got this without solving, you can write at the side that x to the power of 0 is always 1. So you don't have to solve this. So saving time. Second is 6 cube I have to the power of 1/3 gets cancelled, and this is minus 5 to the power of 4, and again change this to 0.25. I gave in my one of the videos conversion of decimals to fractions and fractions to percentages. Okay, so 0.25 is 1/4. I can write this as 25 square, and 2 into 1/4 is half. Again I'll write 25 5 square and cut that half and the 2. Okay, so here therefore you can do both ways, but you have to do 2 steps. So you should know some of the things mentally, children. Okay, 5 cube, 5 4, 5 to the power 5, 3 cube, 3 to the power 4, 3 to the power 5, 3 to the power cube 27, 4 is 81, 3 to the power 4 is 81, 3 to the power 5 is 243, 7 cube 343, 7 square 49, 1 by 7 to the power of minus 2 means 7 square, and that's 49, and so on. Okay, now you get 6. Okay, and then power raised to power not 4 1/4, 4 into 1/4, that is 5, and plus 1. Many people write 0, and this is the wrong answer, because that is my intention of giving the sum. If you have 7 minus 6 plus 1, people write 0. If you have 7 minus half plus 3, people do 7 minus 3 and a half. No, children, no Bodmas when plus and minus are not inserted within brackets. Right? Plus minus means first plus, then minus means plus is which number? 6 and 1 are plus. So 7 and then minus 5 2. Isn't it? It's not that this is plus. How can this is, you're making bracket insertion. You're inserting brackets. If this is like this, then its answer becomes 0, means brackets first. So if you're doing 5 plus 1 first, because plus is not here. The sign is before a number, not behind a number. Okay, so this is, you can, that is why whenever there is minus plus numbers, a series of numbers with only plus minus sign, no brackets, go on in the order of the numbers, right? 6 minus 5 is 1, 1 plus 1 is 2. So if you are again minus 11, so 2 minus 11 is minus 9, there's again a plus 6, then you will say minus 9 plus 6 is minus 3, that way. Okay, do not use Bodmer. That is why I gave you this sum, because you are not supposed to use Bodmer. 6 minus answer is 2, not 0. Answer is not 0. No Bodmers. Yeah, Bodmers in the sense, no Bodmers means not like this. No Bodmers, of course. I will not say no Bodmers, it will be wrong. Bodmers I do, plus 6 and plus 1 and then minus 2. You are doing Bodmers this way, that is wrong. Is it clear? So that is the purpose of giving this sum. Next sum which we go about is this type. Okay, like you have x to the power of a by x to the power of b, and you have a plus b, then into x to the power of b, x to the power of c, then you have x to the power of b plus c, then you have x to the power of c and x to the power of a, then you have x to the power of c plus a. These are called cyclic types. You know, there's a particular pattern, right? So here you will see that people do, first I use the formula x by a, x by y to the power of n, x to the power of n, y to the power of n. So first they multiply with a, some do a square plus ab, some do a square plus b. Children, this whole thing has to be multiplied, remember. This whole thing should be multiplied with a square plus ab. Then this is b, then you can multiply the same power with this, ba plus b square, and then subtract. That is very long, but correct. Right? You are using the formula x to the power of n, y to the power of n, raised to the power of a is na, x to the power of na, and divided by x by nb, me. So, not like that. Subtract inside the bracket you do first. So, that is x to the power of a minus b. In division, we subtract the powers. X power of b, 1 by x to the power of b becomes x to the power minus b. When you make reciprocal of the number, the index sign of index changes. Half you can write as 2 to the power minus 1. Yes, 3 by 4 to the power of minus 2 is 4 by 3 to the power of 2. Right? Or you have 1 by 3 square, it is same as 3 to the power minus 2. So minus b and a plus b both have to be multiplied, brackets. Then you have x to the power of division, subtract the powers. And then b plus c, multiply both, long multiplication. X power c plus a. Why this is wrong? Why this is minus a? So why this is short? Because you know the formula, powers raised to power multiply, and a plus b into a minus b is formula a square minus b square. You don't have to do long multiplication. Do long multiplication because a square minus ab plus ba and minus b square ab and minus ba gets cancelled. So again waste of time. That is why we learn formulas to apply them where it is required. So here it is required, and that a square minus b square, dot means into, b square minus c square dot, or into you can write. Sometimes they give you dot here, that is into. C square, then what do you do? Same base, multiplication sign, we can add powers. Addition, we don't add powers. Subtraction, we don't subtract powers. Only multiplication. So a square minus, so we're adding a square minus b square plus b square minus c square plus c square. So everything gets cancelled. X to the power 0 is not 0. Answer is 1. I also explained to you in the previous video why any number to the power of 0 is 1. Okay. So this is number. So 1 we have done. And the next sum, if you see, the very important one. So just look at this sum. Okay. So I'm giving you variety of sums and indices, right? So if you have any doubt, yes, this is where I have a doubt too. So you can rewind and again see the video and you can make yourself clear. Okay. The next sum which you have is very important, which many of you make mistakes. A plus b to the power of minus 1 and a to the power of minus 1 and b to the power of minus 1. There's a difference. There's a great difference, children. There's a bracket to the power of minus, the whole sum, the sum of a plus b, if you have 2 plus 3, the 5 raised to the power of minus 1. It is not 2 raised to the power of minus 1 and plus 3. This is the whole a plus b raised to the power of minus 1. This is each term is raised to the power of minus 1. Here you cannot bring the minus 1 inside and therefore say both are same. You are bringing the minus 1 inside. You cannot bring the power inside when the sign between the two unlike terms is plus or a minus. That's why a plus b whole square is not a square plus b square. Or a cube plus b cube is not a plus b whole cube, children. Isn't it? So therefore here you cannot bring it inside plus, and only a into b raised to the power of minus 1 is a to the power of minus 1 into b to the power of minus 1. A divided by b whole thing to the power of minus 1 is a to the power of minus 1 divided by b to the power of minus 1. Only in multiplication, division, indices is applicable only for two operations in mathematics. Isn't it? That is multiplication and division. So here this is 1 by a. So this is 1 by a plus b to the power of 1. Okay. And this is individually 1 by a, 1 by b. You cannot take this minus 1 common and like factorization take it whole thing to the power of minus 1. Okay. And then change this to single fraction. Single fraction is LCM AB. So b plus a and b plus a and a plus b. Totality you cancel. If you cancel, because we see many a times, children have this, they write this and this and x plus y. This is totally wrong. You cannot cancel numbers. There's a division sign. The sign between them should be multiplication. X square y square divided by xy, you can cancel the x and y. If there's a plus minus sign, individually you cannot cancel like this. It means sum of x square plus y square divided by x plus y. So BODMAS first. So you cannot do division. You have to add first and then divide. That is why you cannot cancel the thing. So don't cancel BB, AA, that is wrong. And then you write 2 by 2, 1. No. The answer is 1. So now the answer is 1 by AB. So as I'm explaining, I'm not only explaining how to do this particular sum, what all things are being applied in this sum, and what all things you have a tendency to apply which is wrong, right? Your tendency of applying something wrong, okay? And then you have next sum. Suppose you have this 10 to the power of, yes, very interesting now. So now we are going little bit to more, little difficult. So from simple to hard. Suppose I have 10 to the power of 2 by 3 into 25 to the power of 1 by 3 into 50 to the power of 1 by 3. Okay, always children, the powers of the same base, you don't think that you'll always get whole numbers. If you get 5 into 5 to the 1/3, answers 5, 1/3 or 4 by 3. So answer will be like that. When you have like x root x, what is the meaning of the root? I told you last, indices, a radical, irradical sign. When do you use this sign? When the power is a fraction. So this means x to the power 1 into x to the power of half, which is x power 1.5. So 3 by 2, 1 plus half, 3 by 2. Generally you write the index in improper fraction and proper, not mixed fraction. That's all. So when you have like a cube root a, it is a 3.5, 3 plus half, 3.5, 7 by 2, 8 power 7 by 2. Why can't you have irrational? These where your fractions cannot be simplified, the index is a fraction, cannot be simplified, they are irrational numbers. 7 to the power of 3 by 2 is irrational. Okay, 25 to the power of 3 by 2 is rational because you have a complete answer. Right? Now here, how do you do this sum? So this is another kind. If you go back to what all sums I given children, they'll be of different kinds. Okay, I have taught different minds, so I have assimilated all that and have made my sums. So here you will break up into prime factors. 2 into 5 to the power 2 by 3. Prime factors of 25 only 5. So 5 into 5, right? 5 square, 1/3. Okay, prime factors of 50 are 10 5s are, so 10 is 2 and 5. So 2 into 5, 25 2s are 50. So 5 square into 2. So the one which are repetitive, I am writing in exponential form. Now when you multiply, we are doing formula. Now I can bring the power inside. Why? Because the sign is multiplication. Which one we are using? AB, the whole thing to the power of n is an into bn. Why I am bringing the power inside? Because the sign is multiplication. So 2 to the power of 2/3 into 5 to the power of 2/3. 5 to the power of 2/3, not 2 1/3. Power raised to power multiply. A to the power of m raised to the power of n is a to the power of mn. Okay? And then here 5 2/3 and 2 1/3. Now which are the same bases? This and this are same bases. We add their powers. You know 2/3 plus 1/3, mental children, 3 by 3. 2/3 plus 1/3 is 1. So this is 1, and then you have 2/3 plus 2/3 plus 2/3. So 3 times 2/3, 6 by 3. And that when reduced will become 2. Now you cannot make it 10 square. You cannot multiply two numbers if their powers are different. Right? If you cannot say 10 square. First you have to simplify the power, 25. Power has to be same to multiply them. Okay, so now it is 50. Okay, let us go back to some examples. So have you read this? So this type of sum, they are fractions. You're a little worried. I'm getting all fractions. You all want whole numbers. Children, do not make fixed answers in your mind. This answer can only be 24. Answer cannot be 24 by 119. Okay, so it depends on what the sum is. So the method should be correct, irrespective of how beautiful the answer is or how ugly is the answer. So here you have this break into prime factors, the one which are repeating, I'm writing exponential form. Okay, and then I'm bringing the power inside, I'm applying AB to the power of n is an into bn. And then you're doing it. So here remember when you have suppose something like 3 cube into 5 square. It is not 15 to the power of 5. Many children do that. You cannot multiply the bases because the powers are different. First of all, base is same, powers are added. So then what can be done? Only first I evaluate the exponential form and make it a number. So 27 and 25 you have to multiply. And what short multiplication I taught you? 3. So 3, say 9 threes are and 20. So I am going back to my short method. 75 into 9, 45, 4, 63, 67. That's all. Breaking into numbers. Had this 28, then the answer would be 700 because 4 into 25 is 100 and 7 fours are 28, so 700. Okay. So these all, and then suppose you had like this. If you had 3 cube and you had, suppose you had a 2 cube and a 5 cube, okay, or a 2 cube and a 5 cube, right? So then I can write 10 cube, which is 1000, because the power is same. Because the power is same, then I can multiply the bases, okay? And if the base is same, powers are added. If it's 5 cube and 5 square, then 5 I'll write and 5. So see the difference. Different bases, different powers. Different bases, same powers. Same bases, different powers. So 5 to the power of 5. This is multiply 10 to the power of 3. This I cannot multiply, cannot add. You have to simplify this. 27 into 25 and do the sum. Isn't it? So see the variety of sums. And how does a book have variety of questions? Because it deals with variety of brains, right? The next one, which is very important, is suppose you have this, then your 1 minus, then your this, then your 1 minus, then close bracket, then this, and then see how many minuses. This is a little difficult, so let us go. How do you deal about this sum? Okay, we start from the innermost smallest simple bracket. We'll start from there, and every time you have to change to single fraction, like you have 1 minus 1 by x, whole thing to the power of minus 1. So don't think I'll say 1 to the power of minus 1 and 1 by x. No. You can, again there's a minus sign, so you cannot bring the power inside. You have to make this single fraction, that is x minus 1 by x, to the power of, after you make single fraction, negative power, so reciprocal of the base, so x by x minus 1, and then the sign changes 1. So always when you have sum or difference of two fractions, or a whole number and a fraction and raised from negative number, you simplify the bracket, change it to single fraction, and then if there's a negative, you'll make reciprocal. If there's a positive power, you don't make it reciprocal. But you cannot bring the power inside because the sign between the terms is plus or a minus. No. Okay. So therefore, that is the principle. We are going to use it here. We are going to use that principle here. Am I right? So here you have 1 minus, right? So I'll start from here. Curly bracket, 1 minus 1 by x, then bracket. Okay, there's a, yes, 1 minus x, sorry, there's no minus here. Yeah, sorry, there's a minus here also after the sim. So minus 1, then here, this minus, and every bracket has a minus 1 above the power. Simple bracket, minus 1, curly bracket, minus 1, square bracket, minus 1. So here I made it, first single number x minus 1. So 1 by x. Change this to single fraction, don't bring the minus. Again write this, 1 minus curly bracket, 1 minus x minus 1 by x to the power of minus 1. Then a minus 1. So 1 minus gone. Simple bracket gone. Now it's not gone. Yes, it's still there. Now single fraction, reciprocal. So I have square bracket 1, curly bracket 1. This is x by x minus 1, right? And that is x by x minus 1, and then to the power of 1, then curly bracket minus 1. So 2 minus 1 are left. I finish the minus 1 of the simple bracket after changing it to single fraction. Now you will take, this has become positive 1. So now take again 1 into x minus 1. So we continue here, Have you copied this sum, children? Just see. Okay. So just notice after the x, first it starts with x with a minus 1, then there's a minus 1 after the simple bracket. After every bracket it is raised to power of minus 1. So we finished 1 minus 1, but after changing it to single. First I started with this 1 by x, made it single fraction, then applied this reciprocal. So we finished with this minus 1, we are left with 2 more minus 1. But first you have to simplify this. What is within the curly bracket? So we have this, we have finished this. So within the curly bracket I have x and x minus 1. So now we multiply. So this becomes x minus 1 minus x by x minus 1. That is what is in the curly bracket, minus 1. So I'll rub this. There's a 1 minus, there's a square bracket. Okay. And then finish curly bracket, then square bracket, and there's a minus 1 at the end of the square bracket. So now we change it, x gets cancelled. So I'm left with 1 minus, curly bracket has minus 1, x minus 1, and minus 1 and 1. Now, minus 1. So single fraction, ulta pulta. So best I can use the minus and use it here, because I can take the minus down, and minus of x minus 1 is 1 minus x. So I can rightly, so that I don't want this minus here, I can take the minus down with a bracket. So this becomes 1 by 1 minus x to the power of minus 1, and the last minus 1 is outside the square bracket. So now don't multiply, first minus 1, make it positive. So 1 minus x minus 1 by 1 to the power of 1. That's all. So anything to the power of 1 is the same number, and 1 to the power of 1 is 1. But that's all. You open the bracket. So this becomes 1 minus x plus 1 to the power of minus 1. Am I right? Here there's a minus sign, right? So here I got 1. This I made reciprocal, x minus 1 here, and then 1 minus x minus 1. So that becomes 2 minus, so that is 2 minus x, right? So that becomes 2 minus x to the power of minus 1, which is 1 by 2 minus x. Have I made any mistake somewhere? So we start with the sum. Again, you had 1 minus x. It was x minus 1. Okay. So I repeat the sum. The answer is 2 minus x. I somehow feel the answer should have been x, but let's see again. So I have a square bracket, 1 minus curly bracket, 1 minus square bracket, x minus 1, then your minus 1, curly bracket, minus 1, square bracket. This was the sum, children. So let us do a little fast. So it is 1 minus, just to check again, this is 1 minus 1 by x to the power of minus 1, curly bracket minus 1, square bracket minus 1. Again this is 1 minus, curly bracket 1, minus, this is x minus 1 by x, so x by x minus 1, positive 1, okay, minus 1, curly bracket minus 1. So then again you have 1 minus curly bracket x minus 1 minus x minus 1 minus x, that becomes minus 1 by x minus 1, curly bracket minus 1, square bracket minus 1. So since it has become one fraction, it is 1 minus, okay, this minus I used it here, it becomes plus 1 and minus x. I can use it here, I'm taking this minus, or it is x minus 1 by minus 1. So I'll change the sign here, minus x plus 1. So 1 minus x by 1. Okay, this 1 is used. Then I have minus 1. Again single bracket. So it is x minus 1. Yeah. So now it is 1, that is 1 minus 1 gets cancelled. So I made a mistake there, children. I told you the answer was x, so please correct this, the 2 will not come. So I don't know what mistake I did there. I think I must have added here, right? I think I added here. So here it is 1 minus 1. gets cancelled. So x to the power of minus 1 answer is 1 by x. So this answer which I got 1 by 2 minus x is wrong, children. So I checked it again. So this particular sum, I told you 2 plus x was looked to be wrong. So do the same sum as I explained, and I think I wrote a plus sign here. That's why I made it 2. I wrote 2 minus x, just mind it. It was a minus sign, I think I wrote plus. So 1 is minus. So 1, now it has become reciprocal. You can make it x minus 1 by minus 1 also, and minus divided by minus becomes plus. So you'll be left with x only, right? Or I put the sign here. I took the minus in the denominator and changed the sign of both. That's how it became. And then minus 1 is the power 1 minus x. So 1 and 1 gets cancelled. Plus x to the power of minus 1. Answer, again remind children, this answer is 1 by x. Sorry, I made a mistake when in the last step. Okay, I wrote 2 minus x. That was wrong. So answer. So I repeated the sum. Answer is x to the power of minus 1, which is 1 by x. Okay. So this was a little difficult sum. You go home and write the question and do it yourself. And wherever you have doubt, you can see it. And please check that mistake of mine, which I did in the end. That is, I wrote 2 minus x to the power of minus 1. That is wrong. Okay. Now, the other thing, now very important. Now, the very important thing, children, is this. Okay. Suppose you have 125 to the power of n. Suppose you have 125 to the power of n, and then into 15 to the power of 2n into 6 to the power of n plus 1 divided by 27 to the power of n and 6250 to the power of n. There is no addition sign, and the next sum I'll do, I want to see the difference. Okay. All are multiplication signs. All of them are multiplication signs, children. And therefore, you again change it to prime factors. So this is 5 cubed to the power of n. This is 3 into 5 to the power of 2n. And this is breaking up. Okay. 6 to the power of n and 6 to the power of 1. Breaking up, I told you, x to the power of a plus b is x to the power of a into x to the power of b. X to the power of a into x to the power of b is x to the power of a plus b. So, I am breaking up this now. Right? And denominator is 3 cubed to the power of n, and you have 625 is 5 to the power of 4 and 10 to the power of n. Now you can bring the power inside because the sign is multiplication. So 5 to the power of 3n, 3 to the power of 2n, 5 to the power of 2n, then 6 is 2 3s are 2 to the power of n, 3 to the power of n. 6 to the power of n, I am writing as 2 into 3 to the power of n. Okay, and this 6 has power of 1. Then you have 3 to the power of 3n, 5 to the power of 4n, 10 to the power of n. Okay, 10 to the power of n, you are writing as 10 to the power of n. So here you have 3 to the power of, so now you are adding. 10 you are writing as 2 into 5. 10 to the power of n you are writing as 2 to the power of n and 5 to the power of n. 2 5s are. So I am changing this to 2 to the power of n and 5 to the power of n. 2 5s are 10. Now adding the powers of same base. So I get 5 to the power of 5n, adding 3n and 2n, and 3 to the power of 3n, adding 2n and 2 to the power of n, and 6. Okay. Here also I have 5 to the power of 4n and n is 5n, and 3 to the power of 3n, 5 to the power of 5n, into 3 to the power of 3n, 2 to the power of n. Yes, anything else left? I've added, gets cancelled, or 3n minus 3n is 0, 3 to the power of 0, 5 to the power of 0, and 2 to the power of 0, so answer is 6. So this is all multiplication sign, multiplication and division. Okay, so we break them. Now, see the next question which I am going to give you. The next question which I am going to give you, children, okay, is that now there is a plus sign. 3 dot 5 to the power of 2m plus 1 plus 25 to the power of m plus half divided by 5 dot 5 to the power of 2 to the power of m and minus 2 square 125 to the power of m, then again to the power of 2 by 3. Okay. Now what is the sign? There is a division sign. but in the numerator and denominator there is a plus sign. So we do splitting up of indices, right? We split up the sum. So what do you do here? We split up. So this dot means into. So 3 into 5 to the power of 2m into 5 to the power of 1. X to the power of a plus b is x to the power of a into x to the power of b. X to the power of a minus b means x to the power of a divided by x to the power of b. So here minus 5 square bracket, then divide 5 into 5 to the power of 2m minus 2 square is 4, 5 cube to the power of m, and again to the power of 2 by 3. So 5 to the power of 3 is 1 by 25 raised to the power of m. So 3m, okay, and then take out 5 to the power of 2m common, factorization. So when there's plus minus, you take the common term. So now if this is out, 3 5s are 15 is left. 3 and 5, 15 is left. And if you open the bracket, 5 to the power, this will become 5 to the power of 2m plus 1. 2 into half is 1. And 5 to the power 2m is common. 5 to the power 1 is left. Here also 5 to the power 2m is common in the denominator. So what is left? So what is left here? What is left here? 5 and minus 4, because this will get cancelled. Okay. So before that, I think I should simplify further. There's no confusion for you. So this one is 3 into 3 5s are 15. So I'm writing 15. Power is same. 5 to the power 2m. This I'm writing 5 to the power 2m into 5 to the power of 5 to the power 2m plus 1, because I'm opening the bracket. Here it is 5 into 5 to the power 2m, and here it is 4 into 3 gets cancelled, 5 to the power of 2m. Now you are taking 5 to the power 2m common, children. 2m common, yes. You are getting 15 minus 5 to the power. This means what? 5 to the power of 2m plus 1 means 5 to the power of 2m into 5. Yes. So that is 5. And then here, I think I made, there is a plus sign. Plus sign minus plus. So plus. And then 5 to the power 2m common here, 5 minus 4. So this and this has got cancelled. Answer is 20. 15 plus 5 and 5 minus 4. This was plus. This was plus. So 15 plus 5. 5 to the power 1. 5 to the power 2m into 5 to the power 1. 5 to the power, and this was minus. So 5 minus 4 is 1. So answer is 20. Okay. So this is the difference. Now, just before I wind up this, so another say 3 minutes just to do the equations. So how do you do indices equations? So I'll go about, so just with 2-3 examples. You have a to the power of x is a to the power of y. Remember, x is equal to y. That's how we solve exponential equations. Both are LHS and RHS exponential form. That the same base powers are equal, or bases are different but powers are same, then bases are equal. So this logic we use when we are doing equations in indices. Okay. So then you have, suppose 2 to the power of 4x minus 3 and 8 to the power of 2 minus x. So base is different. So 2 cannot be broken up. Please use brackets. This is 2 cube bracket 2 minus x. Power raised to power, we multiply. 2 cube raised to the power of 2 minus. So now base is same, equate powers. So 6 minus 3x. So 7x is 9. So x is 9 by 7. Okay. 2 minus x. Let's see again. 3 2s are 6 and 3x. And here 2 to the power of 4x minus 3. So 4x minus 3, 6 minus 3x. Yes. And then you have 7x equals 9. So 9 by 7. 9 by 7 is 1 and 2, 7. Okay. That is number 1. Another one, suppose you have 7. Okay. You have, so this completes the chapter. 7 dot root of 49 to the power of x equals 1 by 343. All are powers of 7, children. and the sign should be only multiplication and division, no addition. So here it is 7, dot means into, so this is 7 square. Okay, this is 49 to the power of x raised to the power of half, square root, and this is 1 by 7 cube. And the base has to be on top. You cannot equate 7 and 1 by 7. So 7, this is 7 square to the power of x, then to the power of half. 7 square raised to the power of 2x, again 2x raised to the power of half. So into, and this is 7 minus 3. You have to bring it, make the base 7, not 1 by 7. So this will become reciprocal, sign will change, and this is power 1. And this 2 and 2 gets cancelled. So you have 7, 1 plus x equals x ones are x. So 1 plus x equals minus 3. So x equals minus 4. So this is another equations to solve. And the other one before I leave, okay, that is, so 4 by 9. 4 by 9 to the power of 1 minus 2x is equal to square root of 3 by 2, the whole thing, to the power of 5x. So here what do you do? Where you do? Fractions, a by b, both sides the fraction should be a by b. So this is 3 by 2, this is 2 by 3. So I'll make it 9 by 4. Okay, reciprocal, sign will change. It will be minus or 1 minus 2x. And this is 3 by 2 raised to the 5x. And the whole thing, square root means what? To the power of half. Square root means to the power of half. Yes? And therefore, now I have to make base 3 by 2. So this is 3 by 2 square and raised to the power of 2x minus 1. There's one more power. Sign changes. This is also 3 by 2. Please use brackets here. To the power raised to the power of 5x by 2. Now same base. This base, this base. So 2 times 2x, equating powers, is 5x by 2. So 4x minus 2 is 5x by 2. 2 gets multiplied with both. 8x minus 4 is 5x. So 3x equals 4. So x is 1/3. 4 by 3. Yes? So to 4x minus 2. 8x minus 4. 3x 4. Yes, correct. Right? So this is equating the thing. Equating the making. Now suppose you to find base. Like you have 5x plus 1. 5x plus 1 to the power of 4 by 3 equals 16. Now the x, what you have to find is, children, the base. Now you have to find the base. Find x. The question is find x. All these equations, I have to find the values of x. In equations in the exponential form, where we are equating the powers, making the base same, or equating the bases, making the power same, we are finding the value of an unknown. Here the unknown is in the base. So therefore, how do we do this? You know that when you have 2x plus 1 whole square is 9, use a square root. What are you doing actually? Square root means to the power of half. Here also you are doing to the power of half. So here, to get rid of this, yes, what do you do to make this 1? How do you make a number 1? By multiplying with reciprocal. How do you make product of a into what will be 1? It's reciprocal. X by y into what will be 1? Y by x. So I am raising to the power of 4 by 3. Here also you have to raise it to the power of 4 by both sides. Equation should be balanced on both sides. If you are multiplying this side by 3, you have to multiply this side by 3. Dividing by 5, dividing by 5. Subtracting the same quantity both sides. Here I am raising it to the power of, sorry, not 4 by 3. 3 by 4, reciprocal, to make it 1. I am raising it to the power of 3 by 4. So this gets cancelled, 1. So therefore, the power has vanished. And anything to the power of 1, any number to the power of 1 is that number. So here I write root power 4, raised to power 3/4 gets cancelled. So 5x is released from this, and therefore 2 cube is 8. So 5x is 7, x is 1/2. You'll wonder, right? So thank you, children, and hope you understood. All the best. Okay?